Welcome to the Calculus 2 class, everyone. Today we are going to learn about another popular technique for finding volume of solids of revolution. We call shell method, guys. So up to this point, we've used the disk and washer method, where we slice the solid into cross section perpendicular to the axis of rotation. The shell must take a different perspective. Instead of slicing, you wrap the region into the thin cylindrical shells. What are you going to do today? We have to recognize when the shell method is more convenient than disk and washer method. That's the first thing you have to recognize. Second is set up the volume integral using the radius, height, thickness of the shell. Third is evaluate integral, find exact volume, guys. That's we're gonna study this session. Some volume problems are very challenging handled with the wash or disk method. Look at this example, guys. Can you see the blue region right there, guys? Blue region is bounded by y equal 2x squared minus x cubed when x-axis. We want to rotate this region over the y-axis. So you're thinking about Washer method because right here, hole. Then when you think about Washer method, we have find inner radius and you have find outer radius, which meaning is we have find right function, left function. Another way, you have to solve for x. Y equal 2x squared minus x cubed. But it's not easy to solve for x with this function. So that's why I'm gonna introduce new method, because Washer methods had a limitation for this problem. So let's introduce Washer method, guys, okay? Look at this region bounded by y equal f of x equal a, x equal b, y equal 0. That's a blue region. I'm gonna rotate this region over the y-axis, right there, y-axis. Then you have this solid. So which method is working? If we cannot find x equals some function, solve for x, it's very hard to solve for x. Washer method is very challenging for this problem. So I gonna use different approach to find the volume. Imagine rotating region around the y-axis. Instead of cutting perpendicular slice, which meaning is horizontal rectangle which is perpendicular y-axis. Now we're gonna have different approach to solve the problem. So we're gonna think drawing the vertical rectangle within the region this time, not the perpendiculars. Then this rectangle are revolve around the y-axis. Then that form hollow cylinder. Look at this one, right? Look at the right side. That's the like stack of the tin can nested inside each others. We call this one is a cylindrical shell. What is the difference between wash and shell? We're gonna use vertical rectangle, not the horizontal rectangle. Then how gonna find this volume of this slice? Okay, guys, that's we're gonna drive formula for shell method. Look at this picture, guys. Blue region bounded by y equal f of x equal x equal b x-axis. We're gonna rotate the blue region over the y-axis. We wanna find the volume of this one, but we're gonna pick the vertical rectangle. Then we're gonna rotate it as vertical rectangle. Then they created cylinder shell right there, guys. That's the cylinder shell they're gonna create. So how gonna find the volume of cylindrical shell? Guys, look at this one. They have xy delta, that's the thickness, that's the fxy. This very skinny cylinder shell, we want to find the volume, guys. We want to find the volume delta vi. How gonna find this volume, guys? I gonna plot out this cylindrical shell. Cut the middle, guys. Cut the middle, flat out, that have the rectangular. So how gonna find the volume of a rectangular, guys? We have to find the, here is the length, here is the width, that's the thickness. So length gonna be circumference of top. What is radius? Xi. So circumference gonna be 2 pi xi. That's the circumference. Then width gonna be, we're gonna say height. That's gonna be fxi. That's gonna be height. Thickness gonna be delta x. That's the volume of thin cylindrical shell. So that's volume gonna be 2 pi xi. That's the circumference of top, height, fxi, time thickness. Another way we write 2 pi radius from the axis of rotation. Then height, thickness. That's you find the thin volume of thin cylindrical shell, guys. Let's look at the formula for shell method, guys. The shell method, we're gonna use cylindrical shell, very thin cylinder. So how gonna find the volume, guys? How gonna find the volume? Volume gonna be 2 pi radius gonna be distance from the axis of rotation. That's gonna be x. You need height. That's gonna be f of x right there, guys. Then you're gonna do thickness. That's gonna be dx you have. Then you're gonna put together, have the sum of all the volume of thin shell. That's integral a and b, guys. That's you find the volume, the solid, by using the shell method. What is the big difference between shell and washer? We're gonna use vertical rectangle. That's gonna be parallel to the axis of revolution. That's the huge difference between shell and wash method. Let's have first example. So we want to find the volume of solid by rotating about the y-axis of the region bounded by y equal 2x square, x cubed, y equals 0. So this region we're going to rotate it over the y-axis. Then what do you have here, guys? What do you have? That's the, we have solid by rotating about the y-axis. Then how gonna find this volume? So we want to find the volume. Then we're gonna rotate the y-axis. I'm gonna draw the rectangle parallel to the axis of rotation. Another way, vertical rectangle right there. I draw the vertical rectangle. Then this one is gonna be vertical slice. So we have to use shell method. That's the shell method. A and B, 2 pi. Radius gonna be distance between axis of rotation and this one. That's the vertical slice. That's the radius. We need to find the height. Okay, guys? So first the radius. What is the radius gonna be right here? X, distance between two. Then height gonna be 2x squared minus x cubed. That's the height of this shell. Then we're gonna integrate. So volume gonna be 0 and 2. 2 pi x, that's the radius, height gonna be 2x squared minus x cubed dx. We're gonna evaluate u times x, distribute to x cubed minus x fourth power, find the antiderivative x fourth, x4, x3, I'm sorry, x fourth over 4, that's divided by 2, 1 over 2, x fourth power over 2, antiderivative x4 gonna be x5 over 5, from x equals 0 and 2. Guys, very careful. We slice the interval 0 and 2, interval of x, because the thickness is dx. You have to make sure write down the interval of x. Plug in x equals 2, plug in x equals 2, x equals 0 right there, guys. When you plug in x equals 2, 6 over 2 minus 32 over 5, simplify, 6 over 2, 8 minus 32 over 5, that's gonna be 8 over 5, volume gonna be 16 pi over 5. So let's have another example. So this orange region bounded by y equal x, y equal x squared, guys. Y equal x squared right there. So this one bounded y equal x, y equal x squared. We have find the intersection here, 0, another intersection right here. That's gonna be 1. How gonna find intersection of two curves? Y equal x, y equal x squared. You put together. So x equal x squared. You solve for x. That's x equals 0, x equals 1. Now, let's rotate this region over the y-axis, guys, y-axis. So first one is you rotate this region y-axis. Then you have a choice, shell method, Washer method. Let's use the shell method, which meaning is you draw the vertical rectangle right here, then rotate it. They created shell. Shell need radius and height, guys. Shell method need 2 pi radius and height. Radius gonna be distance between axis of rotation and this one, this rectangle, that's the radius. That's gonna be definitely what you have, x. That's gonna be x. Height gonna be distance between two curves. That's why top curve is x, bottom function is x squared. That's the height gonna be x minus x squared. So we have volume is 0 and 1. We find the intersection right there, right? 0 and 1, 2 pi x, x minus x squared dx. Then what you have to do right there, guys? So distribute to x, then you have x squared x cubed. Find the antiderivative of each function, 2 pi x cubed over 3 minus x fourth power over 4, x equals 0 and 1. You plug in the 1, you plug in the 0, that's a half. 1 over 3. When you plug in 1 over 3 minus 1 over 4, that's 1 over 12. 2 pi of 1 over 12 gonna be pi over 6. That's the volume of this solid. We use the shell method. Let's have another example for the shell method. We want to find the volume of a solid by rotating the region bounded by y equal x minus x squared. Y equals 0. That's the blue region. We're going to rotate this one, guys. We want to rotate this one over the x equal 2. So I'm going to using shell method. That's the vertical rectangle. Rotated x equal 2. Then they create a shell. But here's a little challenging part. Find the radius is very challenging, guys. So how gonna think about this radius, guys? So before I talking about radius, let's write down the shell formula. Here's 2 pi, guys, 2 pi radius times height. That's the challenging part, radius. Radius gonna be here, guys. Here is gonna be this one, this point. This is x. So this is x. Here to here, guys, this is x equal to. Radius gonna be distance from x equal 2 to the here, this point. That's gonna be radius, guys, okay? So how gonna find it? X equal to 2 minus x. That's gonna be radius, guys. Make sure that's the 2 minus x is radius. Height gonna be, this is height. Top curve is x minus x squared. Bottom curve, y equals 0. So height gonna be x minus x squared. That's gonna be height. So volume gonna be 2 pi radius 2 minus x times x minus x squared dx. We gonna FOIL this one. You have 2x minus 3x squared plus x cubed dx. Find the each antiderivative. You have x squared minus x cubed plus x fourth power over 4. X equal 1 plug in, x equal 0 you plug in. Then you find 1 over 4. Then answer gonna be pi over 2. That you find this volume. So you might have the question, what is the difference between washer and shell method? I'm gonna give the two different picture, guys. So this is blue region. They rotated over the y-axis. Both them rotated y-axis. This one is y-axis. I draw the rectangle, guys. The first one, rectangle, parallel, vertical rectangle. That's gonna be which method, guys? That's gonna be shell method. The other picture, we rotated this blue region over the y-axis, but I sketched the rectangle horizontally. This is washer method. Okay, guys? So shell method, how gonna find the volume which is generated by this region? Shell method, you have to find radius, you have to find height. That's you have to do it. So 2 pi, volume gonna be 2 pi radius times the height. Thickness gonna be dx, guys. That's the thickness. That's the shell method. Washer method, this is a horizontal rectangle. Thickness gonna be dy. So you need outer radius and inner radius. So washer method, pi. Thickness is this time dy, guys. dy, c and d, outer radius square minus inner radius square. That's the washer method. Which one you're gonna pick? Depends on the question. Which one is much easier to set up? That's the key point. You make a choice which method you're gonna use. So make sure, guys, understand difference between shell and washer method. So let's have example when you're using shell method, when you're using washer method. So depends on the problem, but you might use one of them. So here is a region bounded by y equal 2x, y equal x squared, guys, rotated x equal negative 1. So they generate a solid looks like that. Definitely you're thinking about washer method because there is a hole. At the same time, you're thinking about shell method. Now you have to decide which method you're gonna use. Sometimes it's very hard to use washer method. You definitely use a shell method. Sometimes both methods works for problem. So I'm gonna show to use two different methods. You're gonna see which one is better to find the volume. Let's set up the integral, find the volume of a solid. So first we're gonna use shell method. Okay guys, look at this one. Shell method is this orange region rotated over the x equal negative 1. So we're gonna sketch the rectangle vertically. So thickness is dx, interval gonna be 0 and 2. So shell method say we have to find volume gonna be a and b interval of x, 2 pi radius times height dx. So radius gonna be distance between rotating axis to this one. This one is always x. So this distance from here to here, here is x value minus 1. That's the radius. You have x minus 1, x plus 1. Height gonna be distance between two curves. Top curve 2x, bottom curve x squared. So 2x minus x squared. So you're gonna set up the volume for this solid. V gonna be interval of x is 0 and 2. Region is gonna be 0 and 2. So interval of x comes 0 into 2 pi x plus 1, 2x minus x squared dx. That's how to set up the integral for the volume by using the shell method. Same volume, we're going to use washer method. Just to set up the integral, find the volume of a solid by using the washer method. This time, guys, right here, you're going to rotate this region over the x equal -1 washer method because they have a hole. So washer method, you have draw the rectangle horizontally. So this one is a horizontal rectangle. They create a disk. So how gonna find the volume of this by using the washer? That's gonna be pi. Thickness is dy. Interval gonna be y, 0 and 4. Outer radius square minus inner radius. So outer radius distance between x equal -1 y function, that's the x equals square root to y. So square root to y minus 1, that's gonna be square root to y plus 1. Inner radius is distance between this function x equal 1.5 y, x equal -1, y function is 1.5 y minus 1. Inner radius gonna be y over 2 minus positive 1. So volume gonna be pi integral over y because thickness is dy, 0 and 4. Outer radius square root to y plus 1 square minus y over 2 plus 1 square. That's how set up the integral of the volume by using washer method. What do you learn from this lecture, guys? What do you learn about the shell method, guys? First, we're thinking about shells, not the disk. It's a thin vertical strip revolves into the cylindrical shell. Very thin cylinder. So then we set up with radius and height. Radius gonna be distance to the axis of rotation. Height gonna be different between functions. Don't forget the times 2 pi. So you have volume formula gonna be 2 pi integral a and b x f of x dx. So when do you use it? You're gonna choose shells for simplicity. When you use the shell method, slicing parallel to the axis avoids solving for inverse function or gives easier limit.